Hello and welcome to the 13th episode of the Climate Con podcast. And today I'm joined by Dr. Robert Holmes. We're gonna talk all things about the Climate Con. And this guy, he's been prolific on his YouTube channel for many, many years. And it's been really interesting to see how he's developed some of his perspectives, how they've changed. And I'm pretty sure even you guys who are quite advanced in some of this are gonna have a different perspective by the end of this show. So Robert, would you like to give an introduction to yourself and why people should listen to you about the climate?
Oh, yeah, I've been interested in climate for a long time, probably since the early 90s, really. Um, I have a YouTube channel. I started on this in 2012. It's still going. Uh, I do. I have been to university and completed, well, 4 degrees altogether. I started when I was 50 at university. I did astronomy first. Um, And then I did mining engineering and a master's in environmental engineering. And then I did a PhD in climate science mitigation. Um, for that last one, I cut about 250,000 tons CO2 equivalent from emissions of a mine as part of that last degree. Um, yeah, I realised more in the more recent years that CO2 has less effect than we thought, and in the more recent few years, I think it has no measurable effect. And the data supports that. And as far as I'm concerned, the science and the data support that conclusion.
Okay, yeah, because I was like everybody is at the beginning, or whenever you start getting into this stuff, you get hit with the mainstream perspective of how dangerous CO2 is to everything. And then when I first started coming across some videos, and it was like actually maybe we do want more of this. Maybe it's not so bad. But then from where I'm at right now is that if we didn't have it in our atmosphere, it would be significantly colder. But the level of CO2 we have right now, it makes no difference if we have any more. Is that what you've found? Is that correct?
Uh, no, I'm more of the view that if there was no CO2 in the atmosphere, it wouldn't make any difference to the global temperature, no measurable difference, certainly. Um, and there wouldn't be any life forms on Earth, so we wouldn't be here. It's uh, it's plant food.
Hmm.
There's the very low level of CO2 in the atmosphere now, historically low for the Earth's climate record, and removing CO2 from the atmosphere, like the UK government is doing, is quite insane. But anyway, they're trying to do it, even though the UK only emits 1% of anthropogenic um, so-called greenhouse gas emissions. Um, my more recent research has shown that there is no greenhouse effect. So CO2 doesn't cause any warming, any measurable warming, any different to any other gas. If you added 0.02% of any other gas, it would have the same effect as having as adding 0.02% of CO2 to the atmosphere. On top of that, humans can't really affect the level of CO2 in the atmosphere anyway, because the level of CO2 is controlled by nature, in particular Henry's law. So if we try to remove CO2 from the atmosphere, the oceans will just add it back again. So we're not able to change the level of CO2 in the atmosphere, really.
Okay, and so what about people that say about the CO2 saturation? What's your thought on that? Because that's what I first come to when I first started seeing the alternative views on CO2. Because then it was like, okay, it might have a small role, but it doesn't anymore. But you think it does that doesn't apply at all? And if so, what made you start to think that?
No, it doesn't apply at all. Uh, for a start, there's a terminal conflict between the ideal gas law and the greenhouse effect. Only one of them can be correct. I've published papers on this. So if you consider the ideal gas law, which is not called a law for nothing, it's been measured and many times has been tested and has been found to be accurate, whereas the greenhouse effect has never been discovered. I mean, it's never been found in an experiment. There's there's 30,000 papers published on climate science and greenhouse warming and so on, and yet not one paper is amongst them has has measured an increasing temperature in the troposphere and attributed that increasing temperature to rising CO2 levels. So it's totally unproven. It was just assumed in the 1980s that there was a greenhouse effect, and it's never been proven.
Okay, cool. All right. So what you've got a book that you've written called Climate Truths. Do you want to break down a bit what's inside of there?
Yes, I'm working on this book for a long time, probably 10 years, but finally got it published. And you'll notice this is the same book, but it's got two different covers. So I've got a co-author, Brendan Godwin, who helped me to finish it and did an excellent work, added some new material to it. And we've got two different covers because we had a difference of opinion on the covers, but not the content. So anyway, that's my cover and that's his cover, same inside. You can buy it at climatetruths.com. Yeah, I have quite a few customers in the UK already who've bought the book, which came out about 2 months ago in June, and there's about 500 references to the scientific literature, about 120 figures. Um, when I'm reading a book, I like to see figures, not just text, and you'll find that there's a lot of figures to look at because, as you know, a picture is a thousand words. So. I like graphs myself. I understand graphs, and there's quite a lot in the book that explain this very well.
Okay, great. And what's the chapters? What do you run? What do you go through?
Um, Probably now we've got 14 chapters. The first one really describes the IPCC science of global warming, so-called science. Chapter 2 details that the assumed null hypothesis is incorrect. I won't go through them all, but um, we put forward a competing hypothesis to the greenhouse effect, that is autocompression. That there is a warming due to atmosphere effect, but not a warming due to greenhouse effect. It's just the atmosphere itself that causes warming. Um,
Okay, and is that why you said that if you put any amount of gas in the atmosphere, it would cause that because it's not to do with the greenhouse, it's just because it's causing it's more mass in the atmosphere. Is that it?
yeah, that's right. Uh, it's all backed up by data and measurements.
Sure.
There's a paper published on all the planets, and it shows that wherever you have more than zero point 0.1 bar of pressure in an atmosphere, in a planetary atmosphere or a moon's atmosphere like Titan, um, 10 kilopascals, that is, in the part of the atmospheres that is over that pressure, convection starts. So heat transfer in those areas, which are called tropospheres, when a pressure is over 10 kilopascals, that part of the atmosphere starts convecting. As long as the sun is shining on the planet and you've got over 10 kilopascals of pressure in an atmosphere, convection starts. And what that does is it causes generally about 50% of the troposphere is rising and the other 50% is falling, and it causes a lapse rate. How that occurs is detailed in the book and in my published papers. But in the case of Earth, um, the troposphere is between 5 and 15 kilometers thick until you get to the tropopause. And what a rising parcel of air will do is it'll cool as it rises because it acquires potential energy and loses kinetic energy. And for every rising parcel of air, there's a descending parcel of air, of course, to compensate. And that descending parcel of air gets warmer as it descends. That's because it's losing potential energy and gaining kinetic energy. Now, what does a thermometer at the surface measure? It measures the average kinetic energy in a gas. So if the kinetic energy is rising as you go down, if you descend through an atmosphere and the kinetic energy rises, then the thermometer will show a higher temperature. That's just how it is. That's called the lapse rate. What meteorologists call the lapse rate. In mining, it's called autocompression. And what it does is it causes a thermal gradient in the troposphere, in any troposphere of Venus, Earth, or wherever, Titan, any planet that has a thick atmosphere or moon. And that lapse rate leads to a surface thermal enhancement. In the case of Earth, it's about 33 degrees Kelvin or centigrade. And on Venus, it's hundreds of degrees Kelvin because of the depth of the troposphere on Venus is much greater than Earth's. It's about 50 to 60 kilometers compared to Earth's 5 to 15. So that's the reason for the surface thermal enhancement.
Okay. And so, whilst we're on the subject of gases, so I've got some of your graphs here, and would love to get into some of these. Some of them I sort of get, but some of them I don't. I'd love to see what they are and what they mean. But what about methane's role then? Is it just because if we had like the same amount of methane being added as CO2, would it have the same warming, but just not the greenhouse warming, just the pressure or warming?
Yes, it could be methane, carbon dioxide, nitrogen, oxygen, or any other gas. If you add the same amount, it'll cause roughly a similar amount of warming or cooling.
Mm-hmm.
Um, because the temperature, when you put a thermometer into a parcel of gas, the temperature is determined by the ideal gas law, um, which involves three properties of the gas: the pressure, the density, and the molar mass. So if you add a certain amount of any gas to a gas mix, that will change one of these, one or all of these. It'll change the pressure, the molar mass, and the density. And changing any of those will alter the temperature slightly. But only if it's a small amount of gas, it will alter the temperature only slightly. It doesn't matter which gas it is. The greenhouse effect assumes that the Earth can heat itself with its own emissions, which is not possible. So the greenhouse effect doesn't apply. It doesn't exist. The greenhouse gases, I mean, they work in a laboratory rather in a glass bottle. They capture uh, long wave radiation at certain frequencies, which they do in the atmosphere as well. But the atmosphere is not a glass bottle. It's an open space. It can expand as soon as any warming occurs. The atmosphere will expand and cool again instantly. It's not something that takes time. Um, so this idea that the IPCC has about equilibrium climate sensitivity and transient climate response, they're all disproved. All these ideas are disproved by the ideal gas law, which doesn't allow such things. It doesn't allow equilibrium to occur over decades or centuries. It occurs very rapidly due to a change in concentrations of gases, and only in accordance with the ideal gas law, as I said, through pressure change, through density change, or through molar mass changes.
And I was watching one of your videos where I think you summarized this quite well with an analogy about the two cars. Did you want to give that to the people? I think that would get their head around it quite well.
Yeah, probably the simplest explanation you could give on this is if you had two cars in the sun, one with all its doors and windows open, and the other one with its doors and windows closed. Let's say it's a 30-degree day in the shade outside. Well, uh, we all know that the car with its windows and doors closed will be hotter than the one with its windows and doors and boot open. Well, it's the same with the atmosphere. The atmosphere is open, it can expand and cool. And some satellites are having problems orbiting the Earth, long time satellites, because the atmosphere has expanded a little bit, and these low Earth orbit satellites are now interacting with the upper atmosphere, and their orbits are degrading. Some have even come down. So when the atmosphere warms, it expands and cools again. It's just a negative feedback and one that's not accounted for by the IPCC.
Okay, and so do you think we have recently gone through a period of warming? And if so, what do you think's been causing that?
Yes. Now, if you read IPCC reports, you'll find that there's one climate cycle that they refer to all the time, which is the 11-year solar Schwab cycle. Uh, they've chosen that because it goes up and down slightly, 0.1 of a degree up and 0.1 down, and does nothing. Um, and they've ignored 15 other climate cycles that are found in the literature, totally ignored them because they're not really convenient to their conclusions. Now, um, there was a published paper on 6 European cities where they've measured the temperature in those cities over the last 200 years or so. And the temperature has gone in a certain pattern in the wave in accordance with climate cycles. And underpinning those climate cycles are cycles such as the Yoshimura 61-year climate cycle, the Swiss climate cycle, which is a 220-year climate cycle. Yes, that's it. That's the study. Um, Now, when the people who wrote this paper put into the model these actual measurements, uh, they accorded very exactly with just below that figure. Yeah, there's another figure which shows which shows the predominant climate cycles. The 248-year Swiss climate cycle I was talking about. The 80-year one is the Gleisberg, and 61 is the Yoshimura. And these cycles dominate the climate today, just as they always have throughout the Earth's history, on short time scales like this, human time scales. And the entire period of warming from 1750 to now is caused by these climate cycles and other ones that underpin them, such as the 934-year Bond cycle, and the 2,300-year Bray cycle. So they all piggyback on one another. And altogether, at the top of the cycles, they eventually dictate the temperature of the Earth. Nothing to do with CO2 or greenhouses. So these climate cycles have dominated the Earth's history forever, and they still do today. It's no different now than it's always been.
Okay, and did you want to explain this one because I watched your video when you was talking about this, and I think it's the scientist who made this graph combined the cycles and sort of plotted what he thought would happen. Is that right?
Um, Yeah, you mean predicting the future?
No, for now, because it's like this is if
Yeah.
you see that this one is from.
The black line is the actual measurements of the six cities, and the red line is a combination of the cycles the those cycles I was talking about. Um, the Gleisberg, the Swiss, and the Yoshimura, principally those three, and they cause all global warmings and coolings and climate changes on short time scales like this.
Yeah, and
Um,
what's getting me is that it's due to go down, and I'm very upset about that being in often cold and cloudy UK. I was really hoping we was going to get. When I heard global warming, I was like, yes, please give us some of that because it's
well,
very
the
cold.
good news is it's we're on a high of many climate cycles at the moment. The sun's at a solar maximum presently, hotter than it's been for 11,000 years, and that's why we've got the present period of global warming, which started in 1690 and continues today. That's the good news. And even better news is it's got nothing to do with our CO2 emissions.
Awesome. Yeah, I was going to get into what your thoughts are on the role of the sun. I don't know if it's just me, but I'm sure it feels hotter. Even in my very short life, I feel that it wasn't always this hot. But I don't know if I'm just imagining it or I just appreciate it more. I don't know. Have you got anything to say on the role of the sun and how it may have changed recently already?
It is hotter than it's been. Like the coldest period in the Holocene, which is the last 10,000 years, was probably in 1690, around 1690 when the Thames froze over. And obviously, it's not going to do that now because it's not cold enough. They used to hold ice fairs on the Thames in the 1690s and 1680s, and that was definitely a cold period. And cold periods are bad. I mean, millions of people die from cold. So it's not something we should want to come back. What we want is a good period of warming, which is what we've got, and it's very good, very good for survival. It's good for plant life and it's good for human life. Now, you hear a lot of CO2 proponents say, "Oh, well, it's not the sun because the sun is now cooling." Well, it is marginally. It's a tiny amount of cooling since the peak in the 1960s, 1970s, 1980s. It's very marginal, and certainly solar activity is much higher than it used to be a few hundred years ago. And the present solar maximum, I'm talking about the last few hundred years now, a lot of papers I've seen show it's higher solar activity than it's been for at least 4,000 years and probably 11,000 years.
Okay, and that's just the sun moving through its own cycle. There's no we can measure that. We can sort of assume that's going to happen. And okay, all right.
Yeah, the solar cycles cause a lot of these climate cycles. I've in the book I've shown a chart of 16 known climate cycles that are found in the literature. Yeah, these are the 16 climate cycles I've identified from the literature. The main ones that affect us principally is the Yoshimura. This is the one that was more recently caused of warming in the 1880s, cooling about 1910 and warmed again in the 1940s, cooled in the 1970s and warmed again now. So this is a very strong climate cycle, and it's present in a lot of proxy data going back thousands of years, and it's caused by the motion of the barycenter of the solar system, and related to Jupiter and Saturn's orbit around the sun. So the orbit of Jupiter and Saturn causes a little bit of a wobble in the sun every 60 years. Um, and that causes the Yoshimura climate cycle on Earth. Now, there's also the Gleisberg, which is less important but still quite there. And then there's probably the Swiss, the 220-year climate cycle. This is a total solar radiance cycle and is linked to a resonance of planet Uranus. And then there's a bond cycle, which is related to the angular momentum, which is the sum of the planets and the sun's angular momentum. Then the next, probably the most important one after that for us is the Bray cycle, which is a 2,300-year cycle. This is underpinning our current warming, like the bond is. The bond causes a strong warming every 1,000 years. It caused the Roman warming period, the medieval warming period, going back before the Roman, the Minoan warming period. So the Minoan, the Roman, the medieval, and the current warming period. The bond cycle caused all that. And you've probably heard about the hockey stick that the IPCC put in one of its reports. Well, it's dropped it now, but it was popular in the early 2000s. And the hockey stick was a published paper which eliminated the medieval warm period and the Little Ice Age. So we know that it's a totally fake paper. The IPCC published this in their first report. They were quite honest in their first assessment report in the 1990s, relatively honest anyway. And they used real science. They knew that the medieval warm period existed and there was a little ice age. So this is from the first IPCC report. Instead of that, they now have this this hockey stick idea that that temperature's been flat for 1,000 years, and there's no such thing as climate cycles, which they ignore, as I said before.
That's a nice collection of graphs you got there.
Yeah, I've got these are the ones. These are some of the ones from the book and some others. This one is Neptune, which shows global warming on Neptune. There's also been global warming on Mars um, and other planets.
So what
So
what causes them to heat up? Is that the sun again? Do they
the
have their own
sun, yeah.
cycle? Yeah,
So
okay.
solar activity is at a high.
Hmm.
Yeah.
Okay, cool. Is there any other graphs here you think we should look at before I pull up the ones that I've found? Because yeah, there's loads
Um,
here.
well, ones that are probably the most concerning uh, to me are these is ones like this one here, which is where they've altered the data. The people in charge of the global temperature data sets have altered the data
Hmm.
so that it suits their CO2 models, which is totally ridiculous. They shouldn't be doing it. This shows how they've cooled the past. So they've generally cooled all the past earlier than 1940, and they've warmed the record after the 1940. These are just the changes they've made to the data set. This is not the data set. It's the changes they've made to the data set, the NCDC data set, which is a major global data set. You can see that they've warmed and cooled exactly what they wanted to do to eliminate natural variability. In other words, they've eliminated the climate cycles from the data, and they've made a nice rising graph that matches the CO2 rise.
How convenient.
Yeah, unreal. But anyway, just saying what they did.
Yeah,
And
that's important that people know this.
yeah, Oh, this one here, um, I'll go back. This is the greenhouse gas theory predictions. This is for greenhouse models, and they're predicting a hotspot over the tropics, about 10 kilometers high. This is the North Pole and the South Pole. It's a slice through the atmosphere from the North Pole to the South Pole, and that's the equator. And all the models, all the greenhouse models say that if you double CO2, you're going to get this warming blob over the troposphere, about 10 to 12 kilometers high. Okay. But unfortunately, this is the measurements. That's the North Polar area, South Polar area. In fact, the South Pole is cooled. That's cooling. And the hot spot, there's no hot spot. It's cooled over the troposphere. There's been a slight warming according to the actual data in the Arctic, but as I'll show, that's nothing to do with CO2 either. Hadcrut 3 data, they've gone to Hadcrut 4 and Hadcrut 5 because, as I said, they've altered the data, they've smoothed it to match the actual CO2 record and the CO2 models. But this was the real data unadjusted from Hadcrut 3 from 1850 to about 2015. They stopped collecting Hadcrut 3. And here we've got the Yoshimura climate cycle, very clear in the Hadcrut 3 raw data. Warming in 1880, cooling 1910, warming 1940, cooling 1970s, and warming now. Nothing at all to do with CO2. Now, here's why it's warmed. As I said, the climate cycle has caused warming over the last 40 or 50 years. And this is the reason. The sun might have cooled over the last 50 years slightly, 1 watt per square meter or something out of 1360, nothing really measurable, hardly measurable. But they latch on to that. They say, how can the Earth warm when the sun is cooling? This is how it can happen if you've got less cloud cover. It's in particular tropical cloud cover. If tropical cloud cover falls, like it has between 1986 there, about 66%, and recently when it's about 60%, it's dropped 6% tropical cloud cover. That's caused warming. It's caused the warming from the mid 80s to about the current level, about early 2000s. So these two are related. This is measured data. So the sun can still cause warming on Earth, even when the sun itself is putting out slightly less energy because of cloud cover. The sun is what heats the oceans, and the oceans are the most important thing when you get down to warming of the Earth. If the sun warms the oceans more, the atmosphere is going to be warmer.
And so, what was
Okay,
causing
so
the decrease in the cloud cover there?
what causes the decrease in the cloud cover? Well, this is a climate cycle, and it's got a lot to do with the cosmic ray flux. Now, again, the CO2 people present data about cosmic ray flux and say, oh well, cosmic ray flux, this and that. But what matters is high intensity cosmic rays that come from outside the solar system, not solar cosmic rays. Solar cosmic rays are low intensity. They're not very powerful. They don't really do much. They're stopped by our atmosphere. Um, but cosmic rays from outside the solar system have a strong effect because they're very powerful cosmic rays. They cause a muon shower right through the atmosphere down to the surface of powerful particles that can even penetrate down uh, into the oceans hundreds of meters. And anyway, what they do is they change cloud cover. So if there's more cosmic rays, more high intensity cosmic rays, what they tend to do is cause more clouds to form, more lower clouds to form, which cause cooling. And if there's less of them, then less lower clouds form and you get warming. So this is work by Svensmark and Weiser, um, who did a lot of work on this. I've cited their papers quite frequently in my book. Anyway, this is Greenland. I don't know if you can see this.
Yep.
Um, they all say, oh, Greenland's melting, but it's nothing unusual. This is from, on the left, it's from 1923 to 33, about 1930. And on the right is the current melting of Greenland, which is very similar. So this is again is another climate cycle. It's the Yoshimura climate cycle, and it causes warming and cooling in the Arctic principally, as well as in the oceans. So this is an Arctic cycle. This is long-lived tropical, subtropical storms and hurricanes. As you see over time, well, you couldn't say there's any particular change in those. There seemed to be a few less of them in the 70s, but overall, not much change. Anyway, there's too many to go through, probably. Uh,
Sure. There's any that really you really would like to share.
there's one here which is quite interesting. In the IPCC, um, they have a chart on attribution, what's causing the current warming. And they rely a lot on forcing, relative forcing between what they call greenhouse gases and natural effects, which they boil down to TSI of the sun, really. That's all they consider. And they
What does
say that
TSI mean?
total solar irradiance.
Okay.
So really, the how much output the sun gives to at Earth's distance, really, which is about 13. It's roughly 1,361 watts per square meter at the Earth's distance from the sun. Um, Now the green line is Judith Lean's published paper on this on TSI over the last 300 years. And as you can see, it's not changed much according to Lean. Judith Lean is the only solar scientist that's really been used by the IPCC. So you've got this massive ball up there in the sky, a million times bigger than Earth, which is giving us all our heat and light. And they've only got one scientist out of the 1,200 that they use that actually does work on the sun. It's amazing. Now in red, we've got a paper by Hoyt and Shatton, which of course the IPCC doesn't use because it shows a more realistic level of TSI change over the last 300 years. As I said, 1690 was the coldest period in thousands of years, and that's when the sun had very low activity, almost no sunspots for maybe 50 years at all. So very low activity. And suddenly the sun came to life about 1700. And this is when you got this massive spike in solar emissions, solar TSI, and also the Earth got warmer, a lot warmer. In that 50 years, it got about zero point 0.5 degrees centigrade warmer, which is the most, um, which is a very rapid warming rate compared to, historically. And then we got cooling again, about 1800. And then we got a cool period in the late 1800s. Then we got warming again in the 20th century. And this is where we are now, about here. So, yeah, what's important is the range of TSI, which according to Lean is about 1 watt per square meter, the Earth's distance from the sun. But other works such as Hoyt and Shatton's show a much greater range of TSI. Um, so it goes down to about 1356 actually, so about 6 watts per square meter of the Earth's distance. So 6 times greater range is shown by other work than IPCC authors. Anyway, that's just one example of the problems. This is the Antarctic, which is flat. No warming, no cooling, basically nothing for the last 50 years or so. And the NASA scientists think this is a mystery. I've published a video on this. It's not really a mystery. Um, it's a mystery if you believe in the greenhouse effect, because the greenhouse effect said that the Antarctic must be warming quite strongly, but it's not. Mm, That's Australia's temperatures over the last 50 years, which have also been flat.
Flat as a
Um,
biscuit. That's a great
yeah,
name.
yeah. I mean, we're talking about real data here, not the adjusted data. This is if you compare the real data to the adjusted data. Adjusted data can always be found because you can always tell it because it goes straight up like a hockey stick. Anyway, this is the surface of Venus. Photo from the surface of Venus. Somewhere you wouldn't want to be,
Yeah, because
but
people
not
say that that comes up sometimes because of the high CO2 in Venus's atmosphere. That's what's caused the warming, but that's not correct, is it?
now. No, what causes the hot temperature on the surface of Venus is the accumulated lapse rate of the thick atmosphere, which is about the troposphere is about 60 kilometers deep. And if the lapse rate say 7 degrees per kilometer, you multiply 7 by 60 kilometers and you get the Venusian surface temperature, which I calculated, it's in the book. If the uh, Grand Canyon was 30 miles deeper, then you'd have the temperature of Venus right here on Earth at the bottom of the Grand Canyon. So it's all to do with multiplying the lapse rate by the depth of the troposphere. Oh, this is quite an important graph. Yeah, this is the absorption by water of incident radiation. So coupled with the wavelength of the radiation. So what it shows is that back radiation from CO2, which is about here, 10 microns, cannot penetrate water. Only a few microns. That's all. So back radiation from CO2 cannot warm the oceans. This is the visible radiation coming from the sun here in this bandwidth here, which is shortwave radiation. And that can penetrate right down through the ocean that is 100 meters there. So that's 1 meter, that's 100 meters. So direct solar radiation from the sun can penetrate the oceans hundreds of meters, and it's that that heats the oceans, not the back radiation from CO2. That's impossible. It's far too weak to penetrate and warm the oceans.
This one, I just wanted to get an understanding of what this is because I thought this was really cool. This is clearly a few different timelines or something here. Do you want to explain this one?
That's put out by the in IPCC reports, one of the early ones, and it shows the action that needs to be taken to solve the so-called climate crisis, which of course is not a crisis at all. Um, and it tells you the modeling as to what will happen if we don't do what they say. This is where you get things, you get mad ideas like net zero from governments. Um, I know in the UK you got the same type of government as we have, um,
Yeah, because you're in
left-wing
Australia,
government.
in case anybody didn't know that, right?
Yeah,
Hmm.
yeah. Our government's also pushing this net zero stuff. What the average person doesn't realise is that the net zero that they're working on is only energy production, which is only about 33% of all greenhouse gas emissions from a country is energy production, like electricity production. It's not net zero. It's just cutting the emissions by 33% if they make all energy production uh, so-called renewable. Um, Another 33% of our emissions is transport cars, cars, trucks, planes, that kind of thing. And the other 33% is farming, which they haven't really started on those yet. So that particular pleasure is awaiting us that once they've got to what they call net zero on energy, then they're going to start on other stuff, transport and farming.
Yeah, they seem to be they're making a bit of push for that here. We've got like the inheritance tax on farmers and also the banning of petrol cars and yeah, they're trying all of this insanity and I guess this is related to this timeline here because um they're saying that they're saying about population continually increasing. I mean, that to me sounds like a good thing. It's like something we should actually want. We shouldn't want less people. Because I don't know
Hmm.
if you've encountered this, but when I find people that have gone deep into I call it a climate cult, but once they've gone deep into it, suddenly it becomes like almost like a death cult. Like we need less humans. I mean, what do you think about that?
It's strange how they think we need less humans, and yet they are importing people into countries that have higher emissions than other countries.
Yeah,
You
when
know,
you put it like
I
that.
mean
Yeah.
that does not make sense. It doesn't add up, does it? I mean, they're bringing people from low emission countries and bringing them to the West, and they're obviously gonna emit more. So the whole thing is crazy, and best thing to do about net zero is to just drop it
Hmm.
completely.
Well, we'll do our best. We're leading the charge here in the climate con with the activist side of things, and maybe one day we'll be able to say we defeated net zero. That'd be really awesome. And so there's
Yeah,
a
it'd be
couple
great.
other ones here. So just sort of jump out at me. What are these? Because I was just like, this looks really interesting, but I wish I knew what it meant.
The green line is predictions of various predictions of future climate states by the IPCC's models, driven by CO2. This is what you get. If you drive a model by CO2, you get something totally fake, which is the green line. Um, no, the red line is using climate cycles. And as you can see, the actual measurements, which are in black there, of following the climate cycles, not the CO2 model data. So that's what that is.
Hmm. And so the solar astronomical harmonic model, what is that? 'Cause it sounds pretty interesting.
Um, this is I just forget the name of the scientist, but this is work that he is a solar scientist, and he did on this. Uh, he worked out the solar cycles and made them into a graph form, and he found that the actual measurements, temperature measurements, are following his harmonic model, the cycles instead of the green line, which is the um, CMIP5 GCM models. So we've got the CMIP6 models now, which are supposed to be more advanced, but they don't really, they're still driven by CO2, which means they're not going to work because the climate's not driven by CO2.
Okay, yeah, and so that's the solar activities, the blue one, and then the red one, as you see at the top here, is that combined with the volcanoes. Uh-huh.
Mm,
Okay.
yeah.
And so what does this one mean? This is at the top there, it's got the black body emission curves of the sun and the earth. And
Yes, they can't really be shown to scale because the sun emits the sun peak emissions are 6 million times higher than Earth's. So they're just shown in a sort of representative form here. Uh, the claim is that by the greenhouse people is that solar radiation in shortwave, which is the peak there of the sun, comes down and heats the Earth, and then the Earth turns that into infrared radiation, which it emits. And on the right there, you've got the Earth's emissions of infrared radiation. Um, it looks like they're completely separate. But the thing is that the sun actually emits more infrared radiation than Earth. So even though that graph shows the sun emitting no infrared radiation at all, in reality, the sun emits millions of times more infrared radiation than the entire Earth does. So the sun's graph there should be totally encompassing the Earth. It's a fake graph. It's totally fake, but it's one that they use to push their arguments.
right, I see.
The more
Okay.
correct graph is the one where the sun's emissions totally enclose the Earth's emissions. That's a more accurate graph. Yeah, that is far more accurate. It shows this. It shows the approximate black body curves of the sun and the Earth. Uh, the sun emits. The sun's surface is 5,880 Kelvin, so it has this kind of black body curve with the peak emissions in the shortwave radiation. And the Earth's peak emissions are in the long wave, so about 10 microns. Um, but the sun's peak is actually 6 million times higher than the Earth, and the sun emits uh, at these long wavelengths millions of times more than the Earth does. So their argument is completely false because their argument rests on the Earth being warmed by shortwave radiation, and then emitting longwave radiation, which is captured by greenhouse gases and half reflected back to Earth, which supposedly warms the Earth or keeps the Earth warm. Um, but if those greenhouse gases in the atmosphere are thermalized from above, then the greenhouse effect can't work. So as I said, the sun emits a lot of infrared radiation, And so that means the sun is thermalizing the greenhouse gases from outside. They're not just thermalized from Earth, they're thermalized from the sun directly. The atmosphere absorbs massive amounts of solar radiation direct from the sun. And so um, that's another reason the greenhouse effect can't work.
There we go. So this one, what is this representing here? You see that? Okay.
Ah, yeah. Well, that's really a section through the troposphere, which shows the part of the atmosphere that I was talking about before, which is over 10 kilopascals in pressure. That's what the troposphere is. And because the sun is shining on it, on the Earth, it causes convection to occur. And you get these cells, Hadley cells, and so on. And on the left, you got the North Pole, and on the right, you got the equator there. And because the equator's hotter, the sun is shining directly on it, so you get a uh, higher tropopause. So you get a thicker troposphere at the equator than you do at the poles. So it's about 15, 18 kilometers thick, the equator, and only 5, 6 kilometers at the poles. So this really just shows the convection. Parcels of air rising and cooling, and parcels of air descending and cooling, which creates the lapse rate, which causes the surface thermal enhancement that we observe over what's expected from theory.
Okay, awesome. Well, I could go through that video of all your graphs and we could sit here and unpack every single graph, I think, and it'll still be very interesting information. But I'm aware of the time here. So is there anything else that you'd like to share with the people whilst I got you here? Any closing thoughts?
Uh, yeah. Well, net zero is a dream which is not going to happen, and trying to do it will just cost a fantastic amount of money and probably kill a lot of people. So it's a crazy idea. Um, I mean, windmills and solar panels are not clean energy. They have something called contained emissions. So they emit just as much using a windmill or a solar panel emits just as much CO2 as a coal-fired power station would. I don't know why people think that they're green, because the Earth is not just the UK or Australia. The Earth is the whole planet. And if making those windmills or solar panels, uh, making them uses coal or oil or gas, like it does in China or other places like that, those are still CO2 emissions in the atmosphere. I just don't get it. It just seems to me like it's about virtue signaling. Um, Contained emissions, and secondly, if you really wanted to go to net zero, at the end of my book, I show a couple of graphs about what materials you're going to need. I'm a mining engineer, so I know that you're never going to be able to mine all those materials that you need. A lot of raw earths, you're going to need a massive amounts of copper, lithium, and so on, which we haven't got the world reserves for them. In some cases, the 20 to 50 times what's needed to go to net zero is 20 to 50 times the world's reserves of those minerals. So it's quite impossible and ridiculous to even think that we could do it. Anyway, probably that's all I've got to say on that subject.
Yeah, you can just get once you get going into your sanity, it just yeah, you can rant and rant and rant. But we got to. It is absolutely insane. And we're very passionate here at the Climate Con about stopping this, and we are making waves, and it's really amazing the work you're doing. And so, if people would like to buy your book, where can they get it?
They can get it from climatetruths.com. um, it's um, it's called Climate Truths. I think you can see it. Yeah,
Just on your
it's
website, yeah, exclusively.
quite a thick book. A lot of illustrations, which I like myself, and a lot of references to the literature. And as it says, it's about climate truth.
Awesome. And finally, just give the everyone your YouTube channel because there's a huge amount of information there, and I'm always surprised they haven't found it before I already did not too long ago.
Yes, I've been running a YouTube channel for a long time. It's called 1000 Frolly. Um, I used kind of a non-plume when I started the channel and still continues with the same name. As you can imagine, I've had a lot of threats over the years, and so that's the reason why I didn't use my actual name initially for that.
Sure,
So
I'll put a link to
anyway,
that in the description. Well, thank you for your
yeah,
time, Robert. Appreciate it.
yeah, that'll be good, Travis. Thanks a lot for that, and it's been very good to talk to you.
Nice one.
And I'm glad you're fighting this nonsense in the UK. It needs to be done, I think. Yeah,
Yeah, we're leading the charge and we're making waves. We're gonna stop them.
very good.
Nice one. Cheers, Robert.